At the smallest scales of our universe, the laws of classical physics completely collapse. Here, particles do not exist in a singular location, but rather in a ghostly superposition of all possible states at once. This is the realm of quantum mechanics, where the very act of observation forces nature to make a choice, turning probability into a tangible, concrete reality. This phenomenon, famously illustrated by the double-slit experiment, suggests that reality is not an objective backdrop, but a dynamic participant in our perception. When we measure a particle, we aren't just looking at it, we are effectively dictating its behavior. It raises the haunting question: if we weren't here to observe the universe, would it possess any physical properties at all? Beyond the observer effect lies quantum entanglement, a connection so profound that Albert Einstein famously labeled it spooky action at a distance. Two particles, once linked, share a unified existence regardless of the space between them. If you change the spin of one, its partner instantly reacts, even if it is positioned on the other side of the galaxy, defying the universal speed limit of light. These bizarre findings have led some of the world's most brilliant physicists to propose the holographic principle. This theory suggests that the entire three-dimensional universe we inhabit might be a projection of information encoded on a distant, two-dimensional surface. In this view, our complex reality is little more than a vast, mathematical hologram projected from the edge of space-time. If the universe is fundamentally information-based, it mirrors the architecture of a sophisticated computer simulation. Just as video games render only the parts of the world currently in the player's field of view to save processing power, the quantum universe seems to defer rendering physical reality until an observer intervenes to measure the data. The fine-tuning of our universe adds weight to the simulation hypothesis. From the strength of gravity to the electromagnetic force, if these values differed by even a fraction of a percent, stars wouldn't ignite, atoms wouldn't form, and life would be impossible. The precision required for our existence feels less like a cosmic accident and more like carefully calibrated programming. Critics argue that the simulation theory is unscientific because it cannot be proven or falsified, yet the search for glitches in the code continues. Researchers are looking for pixelation in the cosmic background radiation or patterns in high-energy cosmic rays that might reveal the underlying grid of our artificial reality, searching for the hardware beneath the software. Whether we inhabit a physical cosmos born of random chance or a sophisticated construct designed by an unknown intelligence, the mystery remains. By studying the quantum realm, we are not just learning about atoms, we are decoding the source code of existence itself. As we peel back the layers of reality, we realize that we are both the creators and the characters in this grand, unfolding experiment.